Hey guys, so this lesson is about dimensional analysis and counting atoms. We've done dimensional analysis. We did it earlier this year when we were doing unit conversions, but we're going to continue to do it more and more with different types of problems. So this is just kind of getting us back into that swing of things. So there's a few things you've got to know here. Sometimes it will tell you the conversion in the problem, just like this first problem that we're working on. Here we go. Okay, so this first problem that we're working on tells us that the mass of an atom, which means one atom, of argon is 6.63 times 10 to the negative 24th grams. So that means I could say one atom of argon is the same as 6.63 times 10 to the negative 24th grams. Okay. Or I could say 6.63 times 10 to the negative 24th grams is the same thing as one atom of argon. All right, so remember how we talked about conversion factors. They have to be equivalent to each other, but they usually have different units. So this unit would be grams, this unit would be atoms. So then our question says, how many atoms are there in 40 grams? So if you remember how we set this up, I'm going to do it at the bottom here because I have more room. If you remember how you set this up, you always set it up with the number in the problem. So here's our real problem. This is just our conversion factor. So we're going to start with 40.0 grams of AR. Okay, so that is the number that is given to us in the problem, the number that we're going to start with. This is our conversion factor, so that's what we're going to use next. Now, if you remember anything about this from before, whatever unit you have here should be in the denominator of your conversion factor. So I need the 6.63 times 10 to the negative 24 grams in the bottom and my one atom of argon at the top. The other reason this is important, the first reason is that the grams will cancel because they're opposite of each other. This is in the numerator, that's in the denominator, the unit will cancel. The other reason this is important is because the question is actually asking us how many atoms we have. So we want the grams to cancel. We want our unit at the end to be atoms here. Okay, and now we're ready to do our math. So we're going to multiply by what's on the top. So 40 times 1 is 40. And then we're going to divide by the number on the bottom, 6.63 times 10 to the negative 24. So I'm going to put this in my calculator. So I'm going to say 40 divided by 6.63. Now, I like to use the EE button, which is the comma, so I'm going to put in second EE, which it only shows up with one E on your screen, and then negative 24, and then enter. When you do this, a couple things happen. It does the order of operations for you, so you don't have to use parentheses. And I think that it's just more efficient than using times 10 with the little caret button. So your answer for number 1 is going to end up being 6.03 times 10 to the 24th atoms. Now, this is important. Remember to look to the very, very end of your number. If you see E24, E means the same thing, is times 10 to the. That is what E equals. So when you're writing it out, you're going to write times 10 to the 24th power. Okay. No, I don't know where my pen tool went. That's not what I want to do. That's not what I want to do either. Well, that's not what I want to do either. Well, dang it, I can't find my pen to erase. There we go. Erase. All right, or clear. Yeah. All right, so I'm going to erase this real quick, and then we're going to do the next problem. All right, so our next problem talks about radius. So it doesn't really matter what we're focusing on. The main point of doing all of these problems right now is just trying to get you guys used to going between units again. So The next problem says we've got a radius of carbon is 0.77 times 10 to the negative 8th centimeters. What is the diameter of the atom in nanometers? So you've got a couple ways you can do this. You can remember the ladder and how far centimeters are from nanometers, or you can remember this, that for every 10 to the 9th nanometers, there is 1 meter. Okay, so every 10 to the 9th nanometers is the same thing as 1 meter. So the other thing you need to know here is 100 centimeters is equal to 1 meter. So if you know both of those things, then you can solve this problem pretty easily, because we're going to go from centimeters to meters, then we're going to go from meters to nanometers. So we're going to start with 0.77 times 10 to the negative 8th centimeters. Now our conversion factor, this is the same thing as a conversion factor. I need to have my centimeters on the bottom so that they will cancel, and my meter on the top. So now I've used this one. And then my next one, I want my meter on the bottom, so it's opposite, so it will cancel. And then my 10 to the 9th nanometers on the top. So now if I go through here, my centimeter part cancels, my meter part cancels, and I'm left with nanometers as my answer, which is what I want in my problem. So I'm going to multiply everything across the top. So I'm going to say 0.77, go back. Just kidding. There we go. 77 times. So I'm going to say e to the negative 8. Come on. Times 1 times 10 to the 9th. So that's everything on the top. Now I'm going to divide by what's on the bottom, which is 100 times 1, which is 100. Why did I do that? Just kidding. Come on. Come on. There we go. All right, so that's my final answer. So my final answer should be 0.077 nanometers. Okay, now I know some of you guys say, well, Ms. Watson, you could have just used the ladder to go from centimeters to nanometers. That is true. However, part of the reason that I'm teaching you this is I'm teaching you the process to be able to set up your problem and solve it like this, because we're going to use it for things that you really can't use the ladder for. So the next problem says we have a diameter of hydrogen that is 212 picometers. So PM means picometers. Okay. And I know that there are 10 to the 12th picometers in 1 meter. Okay. So it wants to know in kilometers the length of a row of 6.02 times 10 to the 23rd hydrogen atoms. All right, so I have this many atoms. And I want to know how long this is. So I know that each atom is this long. So for every one atom, that is 212 pm. So now I'm going from atoms to picometers. So then my atom part cancels. Then I'm going from picometers to kilometers. I don't want to go directly there because I think that's kind of far. I'm going to go from picometers to meters, and then I know that there are 1,000 meters in 1 kilometer. So I'm going to use these two conversions for that. So the first one I'm going to use is the picometer. I'm going to put 10 to the 12th picometers on the bottom and 1 meter on the top. That way my picometers cancel. And then for the last one, I'm going to put my 1,000 meters on the bottom and my 1 kilometer on the top. so that my meter part cancels. That's the trick, is you got to make sure that whatever's in your numerator here, it has to be in your denominator here. That's how you know how to set this up. Okay, so now you're going to multiply all your numbers across the top and then divide by what's on the bottom. So what that means is the number that you start with, remember, is always in the numerator. It's like saying this number over 1. So I'm going to take 6, come on, 0.02, and then I'm going to do E instead of times 10 to the 23rd. I'm going to do E 23. Then I'm going to multiply by 212. And then you could say times 1, because that's everything on the top. And then I'm going to hit enter. So that's everything on the top. Then on the bottom, I'm going to divide by 10 to the 12th, and then I'm going to divide by 1,000. So I'm going to take that answer and divide by 10 raised to the 12th power. And then I'm going to divide that by, come on, 1,000. And then that's my final answer. So 1.28, I'm going to round that 7 up because of the 6, times 10 to the 11th kilometers. Okay, so a lot of times the most important thing here is a lot of times it's going to give you some of your conversions in the problem. So make sure you're watching out for that. Actually, let's see if I can just go up without having to erase everything. Come on. Kinda. Okay, that'll work. All right, so now let's look at this last problem. It wants to know how many atoms of aluminum there are in a piece of foil that has a volume of 2 centimeters cubed. And then it tells us the density of aluminum is 2.702 grams per centimeter cubed. Okay, so the first thing we want to know is how many grams of aluminum we have. Okay, so we're going to start with this. We've got 2 centimeters cubed. And then we're going to be able to get to grams by using this conversion. So this tells me that for every 1 centimeter cubed, I have 2.072 grams. So when I do this, it's going to give me grams of aluminum. All right, so I'm going to cancel this out. I'm going to cancel this out. All right, so I'm going to multiply this. So I'm going to say 2 times 2.7. All right, so now that gives me 5.404 grams. Now, it doesn't ask me for grams, it asks me for atoms. So we have to find a way to get from grams to atoms. Now, I haven't introduced this concept yet to you guys, but I'm going to go ahead and show you how to do it, and then we'll talk more about this later on. I'm trying to decide if I'm going to go ahead and do it before Christmas or not. So I'll talk to you guys about that on Thursday. So there's this concept in chemistry called the mole, M-O-L-E. And the mole is actually a unit of measurement. So what we say in chemistry is that a mole is 6.022 times 10 to the 23rd atoms. Now, why do we use mole? Well, when you're talking about atoms, they're really, really small, and we don't always like using this scientific notation. Plus, it's not very practical to talk about individual atoms because they are so small. It's way more practical to talk about a collection of atoms, which is what the mole represents. So kind of like we say that if we have 12 of something, that is 1 dozen. That's the same thing. Like dozen is kind of a weird word too. That's the same kind of idea. That's how we count something that means 12. 1 mole is how we count something that means 6.022 times 10 to the 23rd. So the reason this is important is the only way you can go from grams to atoms in chemistry is to go through the mole. And the only way that you can do that is to use the periodic table. So we talked about the average atomic mass on the periodic table. So for aluminum, okay. All right, so for aluminum, if we look on the periodic table, it tells us that we've got an average atomic mass of 26.982 on this particular periodic table. 26.982. So what this number means, it is not only just atomic mass units, it's also how many grams are in 1 mole of that element. So I can use the periodic table to figure out how many grams are in 1 mole of any element on the table. So in this case, this is specific to aluminum. So I have this many grams of aluminum in every 1 mole of aluminum. And the same thing is true for any other element on the periodic table. If I wanted to know how many grams of hydrogen I have in every 1 mole, I would look, and it's usually 1.008 grams of H for every 1 mole of H. Whenever you find the number on the table, that's going to go in your numerator and be with grams, and 1 mole of whatever you're talking about will always be on the bottom. Okay? Now, this is also a conversion factor. This is how many grams are in 1 mole. This is how many grams are in 1 mole. The only difference is that this conversion factor is going to change depending on what substance you're talking about. So here we are. We know now that we have this many grams of aluminum. We want to get to atoms. So I know if I take, erase this one over here. I'll erase my 12 dozen. So I know if I take 5.404 grams of aluminum, if I want to know how many moles that is, I'm going to put my grams on the bottom. So that'd be 26.982 grams on the bottom and 1 mole on the top. So I can flip this just like I can flip other ones. So now my grams cancel. And then I also know that for every 1 mole, I have this many atoms. This isn't always, no matter what substance you're talking about. So for every 1 mole, I have 6.022 times 10 to the 23rd atoms. So then I'm going to do the same thing I just did before. I'm going to multiply across the top. So I'm going to take 5.404 times 1, which I don't have to put in there, times 6.022. Then I'm going to use E to the 23rd. I'm going to go ahead and hit enter because that's everything on the top. So that's my number on the top. Then I'm going to divide by the molar mass, which is what we call this conversion, 26.982. Enter. Okay, so then that is my answer. So that means that for every 2 centimeters cubed, I have 1.21 times 10. Look all the way to the end of the number. You see a 23 atoms. That's how many atoms I have in that volume of aluminum. Okay, we will do more problems like this. This is just an introduction. So look for that. Next week, we're going to do more mole problems like this, and I'll talk to you a little bit more about molar mass and all of that and what that means. Okie dokie. Thanks, guys.